Okay, now we try to look at the example for compare and branch instructions. So how do we write the program which has compare instructions and must be same with the branch? So we will use either unsigned or signed branch, because we have branch higher or same, branch lower or same. Okay, the example same. We want to put the data that is AE into 100 locations of memory. So what we choose for the comparison? For the example, we choose the last address to be compared with the previous address. Okay, so the last address. So what is our last address? So if the starting address is 850, 850 is the first memory address. So we want to insert AE here. And then we have 851 is the number 2, the second one memory, and the 100. So what is the address for the 100? So how do you want to calculate? So what you have to do, 850 in hexa, you have to convert 100 into hexa. So you will get 64, but you have to minus with 1 because we start with 0 here. So you will get 8B3. So the last address is 8B3. So we will compare this address with this address, this address and this address until it find the same address. Okay. Okay, so example, we have the flow chart here. So same AE, we insert into A. Okay, AE for the starting AE, insert into A. And then B is the comparison value. So before this, we are using B as a counter. Now we are using for the comparison value. But why we use 8-bit? Why not we use 16-bit? Because the memory size is 16-bit. Because why? Because the 8 here is same with other. So the difference is just 8-bit. That's why we just use B as a comparison. Okay, comparison storage. And same, we will put X 850. Okay, why we need for store the value of increment of the memory? Why? That's why we put 840. And then next, whatever in X we will insert into memory pointed by Y. Whatever in X, it will insert into memory pointed by Y. So we have here 840. So it will copy the value 08, and then 841 will copy the value 50. Okay, remember X is 16-bit, so we have to use the 2-byte memory. And then next, what we have increase X by, A insert into memory pointed by X. So what we have in A, we have AE. AE will be insert into first memory, that is 850. Okay, and then next we will increase X by 1. So X will be 0851. Okay, and then now X 0851 will be insert into memory pointed by Y. So our memory 840 and 841 will have the new value 0851. Okay, before is 0850, so now 0851. Okay, And then same A, that is AE insert into 851. Okay, because our X is increased here. And then what happened next? We have to compare B with Y plus 1. We have to compare B. So what we have in B? We have B3. So we will compare B3 with Y plus 1. Memory pointed by Y plus 1. So Y plus 1 is, this one is Y, this one is Y plus 1. So we compare here. Okay, now it's changed to 51. So now we compare B3 with Y plus 1. Memory, memory pointed by Y plus 1, that is 51. And then is it same? So not same. So if no, loop again. Okay, so you see the flowchart, you have to modify the flowchart. You cannot put the branch instruction here to be no here, so you have to put yes here. You have to change. Okay. You have to change to yes. So you have to change B minus equal memory pointed by Y plus 1. So you have to change to not equal. So it will be yes to be loop. And this one is N. So do we have branch instruction for not equal? Okay. For signed and unsigned branch, we don't have B not equal or B equal. We just have only B higher or same, B lower or B lower or same. We don't have we don't have B equal, we don't have B. We don't have this in HCS12. So you have to change this condition. So we want it loops, B3 must be bigger, right? Must be bigger than Y plus 1, so it will loop. Okay, you have to change to B must be bigger than Y plus 1. Okay, so it will loop. So what type of branch instruction you have to use when branch B is higher? Okay, just look at the table back. Okay, better we use unsigned branch because we just compare the unsigned value. So for the higher, we use BHI. Okay, now we have the instruction here, BHI, branch higher. Okay, now you can change all the instructions to the code, okay, to the assembly language. Okay, compare B with Y plus 1, memory Y plus 1. This one is memory. I use a notation for bracket as a memory pointed by the inside here.